For decades, modern societies have been optimized around one main goal: efficiency, doing things faster, doing them cheaper, and doing them with fewer resources. Efficiency sounds like progress, and in many ways it is. But there is a trade-off most people never see.
Investorms.org.
Efficiency removes safety margins, and safety margins are what make systems resilient. 1. What a safety margin really is. A safety margin is extra capacity that is not being fully used.
We had no rain this year, but we have a lot of water.
Spare inventory in a warehouse, extra staff on a shift, backup systems and infrastructure, financial savings set aside. These things can look inefficient because they are not producing immediate output. But they exist for one reason: to absorb shocks when something goes wrong. Safety margins are like shock absorbers. You do not notice them when the road is smooth. You are grateful for them when it is not. Section takeaway. Safety margins are unused capacity that protect systems from shocks. They may look inefficient, but they provide stability when conditions change. 2. How efficiency removes those margins. When systems are optimized for maximum efficiency, spare capacity is reduced or removed. Inventory is minimized to cut costs. Staffing is kept lean to boost productivity. Budgets are tightened to improve financial metrics. Supply chains are streamlined to reduce delays. Everything runs closer to its limits. This works well when conditions are stable. But when something unexpected happens, there is less room to adapt.
We had no rain this year. We are out of business.
Efficiency makes systems lean. Lean systems are productive, but they are fragile. Section takeaway. Efficiency reduces spare capacity. Lean systems perform well in stable conditions but struggle under disruption. 3. Why efficiency looked like pure progress. During periods of growing surplus, efficiency felt like a clear win. Energy was abundant. Materials were easy to access. Labor forces were expanding. Systems could be optimized without immediately feeling the loss of buffers. But as surplus tightens, removing safety margins becomes riskier. Systems now operate closer to physical limits. When stress increases, there is less slack to absorb it. What once looked like smart optimization becomes a source of vulnerability. Section takeaway. Efficiency felt harmless when surplus was growing. As surplus tightens, the loss of safety margins becomes a growing risk. 4. Efficiency transfers risk. When a system removes buffers, it does not eliminate risk, it transfers it. From inventory to delivery schedules, from spare staff to worker burnout, from public reserves to emergency spending, from redundancy to dependence on smooth conditions. On paper, the system looks more productive. In reality, it becomes more sensitive to disruption. Small delays, minor shortages, modest shocks now create outsized problems. Section takeaway. Efficiency does not remove risk. It shifts risk into the future and into the system's weakest points. 5. Why this matters today. Modern systems are highly optimized. Just-in-time supply chains, lean staffing models, tight financial structures, minimal redundancy. These designs assume stable conditions, but when stress builds from energy constraints, resource limits, or shrinking surplus, efficiency leaves little room to adapt. That is why we see small disruptions causing large delays, minor shocks triggering big reactions, systems that feel fine until they suddenly are not. The issue is not incompetence. It is that systems built for efficiency are now facing conditions that require resilience. Section takeaway. Highly efficient systems can become fragile when conditions become less stable. What once increased productivity now increases vulnerability. 6. The perspective shift. Understanding this changes how you interpret modern problems. Instead of seeing random failures, bad management, unexpected events, you begin to see a deeper pattern. Systems were optimized for smooth conditions. They are now operating with less slack in a more constrained world. Efficiency improved performance in the past. Resilience will determine stability in the future. The goal is not to reject efficiency. It is to recognize its limits. Section takeaway. Seeing the trade-off between efficiency and resilience helps explain why modern systems can feel both advanced and fragile at the same time. When something fails, do not only ask what went wrong. Ask this instead: how much safety margin was removed before the failure occurred? That question helps you detect the same patterns in the future. Welcome to InvestStorms, where we see the system beneath the noise. Access the full course materials and join our community by scanning the QR code or clicking the link in our bio.
Do you want to learn how I made this video? This video was built frame by frame, graphic by graphic. I screen recorded the entire process, including editing, preparing the script, AI use, and when human verification is needed. Also, it includes building the YouTube listing and thumbnails, using testing mode of 3 different titles and thumbnails to get the best possible results. Everything is shown on video. The full walkthrough will be posted in the classroom section of our school, including this part that you are seeing now. Joining our community is now free by clicking the link in the comments or scan the QR code on the screen.